I'm Alex.
Hi, I'm Join.
Hi, I'm Lucas.
Hi, I'm Sam, and we are IRS Intermediary Rocket Solutions.
Over the past semester, we've been designing a rocket launch rail for the UTS rocketry team.
We are all completing bachelors in mechanical engineering and have had professional workplace experience throughout our internship program.
This design report has been brought to you to demonstrate what we have achieved as a team.
The UTS rocketry team's existing rail support structure for medium rockets is limited in height, ease of use and compatibility due to a vertical design intended to remain fixed. This current design utilises pre-existing components in the form of a square lighting rail from the UTS lighting department used for support. However, it makes it difficult to mount the rocket itself by means of tilting the rail tower, as well as requiring further spaces to accommodate the existing fins on the rocket. Weather conditions such as wind speed and direction will also determine the optimal launch specifications for the rocket, something that the current rail design fails to account for.
This allowed for a specific goal to be outlined for the project, which was to design a system that could be used to stabilize medium to large-sized rockets until they reach a safe speed for liftoff. Similar to the image design shown on the left, it will adhere the UTS rocketry team requirement regarding its directional capabilities for loading and rotational adjustment as well as its overall simplicity.
So, to summarize our design criteria based on the project goal, the assembly must be weight efficient and easily transported in any type of vehicle, whilst being easily constructed and deconstructed so it can be effectively moved between the locations frequented by the rocketry team. The project design featured triangular support trusses that will assist with the 100 kg rocket loads, intended to be separated for travel whilst allowing for a simple mounting to accommodate the rocket fins and the small 2 metre or maximum 6 metre liftoff guiding rail itself. The most favourable requirement includes the rocket rail's degrees of motion, which allow for the efficient and safe mounting of the rocket through its capability to tilt to a horizontal level. This is powered by a 12-volt battery, whilst also allowing for the rotation to a full revolution and tilting to the optimal launch characteristics for the rocketry team.
The structure also accommodates various launch terrains such as the fine dust areas frequented by the client, where stability is essential through telescopic supporting legs. These have the potential to extend or contract to stabilize the entire tower in the appropriate direction relative to the rocket's launch angle and loading configuration. These supports have the capability to include a rocket thrust deflector plate, ensuring the safety of users and longevity of the system and launch environment. We prototyped a 3D printed tilt bracket and small proof of concept prototype to test ideas, core concepts and elements of risk for our design. Here we have our 3D printed tilt bracket, which we created to visualize how the rail structure would be fastened to the base system. We were able to deduce that this part was not viable and therefore redundant. Here we have a video of our small proof of concept prototype, made with pre-existing materials found at home, including binder clips, cardboard and fishing line. The rail represented by the binder clips is held in tension by the winch cable represented by the fishing line. From this view you can see the base plate and rotational system represented by the skateboard wheel and bearing. You can see how the design is able to rotate 360 degrees in any direction and operate in any plane. You can see how the rocket launch rail is lifted and lowered. By visualizing the hand holding the fishing line as the winch, you can see how the winch